So we're supposed to determine whether the sequence is bounded, whether it's monotone, and increasing or decreasing. So a sequence is bounded if there's one number where it can never go below that number, or if there's one number like maybe it's 27 and it can never get above 27. That would be an upper bound, and if it could never go below -2, then the -2 would be a lower bound. So we can start listing out some terms to try to get an idea of what the sequence is going to look like. So we could do n equals 2, n equals 3, n equals 4. If you plug in 2, you get 2 over 2 to the second, so that's 1/2, right? If you plug in 3, I'll just evaluate it. 2 to the third is 8. If you plug in 4, 2 to the fourth, 16. So this is 2 over 4, 3 over 8, 4 over 16. The fractions are getting smaller and smaller, right? This fraction is 0.5. This, if you pull out your calculator, that's 0.375. This is 0.25. So this is getting smaller and smaller. So does it ever reach any sort of minimum, or can it keep going to negative infinity? Can the fractions keep shrinking? If you think about it, think about all the numbers you can plug in here. You can't get any negative numbers out, right? Because n is greater than or equal to 2. So you're only going to get positive numbers up here, and this is always going to be positive. So you can only have positive numbers, but the fractions do keep shrinking. So this is bounded below, and the bound is m equals 0. I think our text uses lowercase m, but either way. Bounded below. 0 is the lower bound. Does it have an upper bound? Is there a number that it can go no higher than? Since it's constantly decreasing, the fractions keep getting smaller and smaller, then it does have an upper bound. It's the first number we have. 1/2 is the upper bound. So it can't go below 0, and it can't go above 1/2. So since it's bounded below and bounded above, we just call this sequence bounded. Okay, we don't say it's bounded below and above. We just say bounded to imply that it's both bounded above and below. So that's the bounded part. I think we've already taken care of the increasing and decreasing part. This sequence is decreasing from term to term. And then whether it's monotonic, it's monotonic if it's constantly decreasing. If it was to fluctuate, to go from decreasing to increasing, decreasing, that is no longer monotonic. But this is monotonic. It is a monotone sequence, okay, because it is constantly going down. And again, if it fluctuated, if it went down, then up, then down, then up, then it would not be monotone.